I may be a bum, but I'm not dumb. It's time for Bum Knowledge Corner. Hello, YouTubers. I am the Car Bum, and today on Knowledge Corner, I'm going to go back to doing some math stuff. Now, as you can see on the screen right now, there is a nice little 4x4 little square, so a 4 squared. Now, the first thing we're going to be talking about is, and you'll notice I'm using MS Paint. Yes, MS Paint is great. But we're going to be talking about just a little math tricks that might make your life a little bit easier. This first trick is going to be uh 2x to the squared is actually exactly the same as uh x squared times 4. So this is the first bit of knowledge that we're going to be working with. Let's just put that right up there. I'll probably erase that in a moment. Why does it take so long now? So it's a very simple way to illustrate this. We have a nice little thing right here. We have 16. And if we quickly copy and paste it to square it, we'll go that way and that way. And as you can see, just by doubling the size, it's actually timesing it by 4. I like it. Yeah. Now, you might be wondering why this might be useful. Well, not everybody knows multiplications up to a certain point. Definitely don't know squares up to a certain point. So this could be useful as like, okay, you told me to do 32 squared. Oh wait, no, 8 squared? Well, most people do know 8 squared. But, but, like, 4 times 4 is of course equal to 16. And then 8 times 8 is of course equal to 64. But if we continue on, 16 times 16 equals to but we can change that to 16 times 16 is equal to 64 times 4. Times 4. Um and that's easy enough. 4 times 4 is 16. And then we just add Uh, 4 times 6 is 120. And then that equals 120. Why am I doing 120? My brain doesn't work sometimes, people. This is an ongoing issue in my life. 240, which is like, and when you just add those together, you get 256, which is 1 byte. Just for those who are interested in computers. So it's very good to try to figure out multiplications that you don't already know, especially squares. But it does also work for other things too. Like, let's say you have, no, I can't do 5. That's easy. Let's say we have 22 times 36. Well, I don't know what that is, but 11 times 18? Well, that's easy. That's 198. And I can still use this for that as well, so then all I have to do is times that by 4. And when we get 4, 3, so we have 4 times 8, which is of course 32, and then we have 36, and then we would have well, 400. So and that of course then would be 4 plus 3, it would be 7. 2 plus or 3 plus 6, it would be 9, and then 2. And those whose brains actually work better than mine could easily mental math this stuff faster. And so that's why I have here. As you can see, it's a little bit easier because I don't want to multiply 30. I don't like doing this because if we would do it the traditional way, we would have, okay, we have 12, and then we would have to add the 3, or 3 times 2 is 6, and then 2 times 6, and then plus 2 times 6 is 12, and then 3 times 3 times 2 is another 6, and we would still get to the same answer. Wait, why do I have 198? Oh, wait. 100. Wait, what was the other answer I had? Did I screw up somewhere? I probably did. No, it was 792. Yeah, okay, that made sense. Yeah. I think that was what I got before, right? Probably should have left that out as a little note somewhere. Yeah, should have done the equal there and then. But either way, this just it's just easier to deal with smaller digit numbers. Of course, this doesn't work when you get. Well, actually, no, it kind of does. So yeah, that's it for this part of it. Now we're going to go to our next little theorem, which is also about squares and equivalent type of things. And it has to do with how squares actually work. So when advancing from one square to the next, we have x plus n, and put all that into square, or put times those together. 2 is equal. This one's going to be a little bit longer. X squared plus n squared plus 2nx. 2xn. Okay. Now this one's a little bit more, but like big, but it's really not that complicated. Let's use this right here. Let's start with this. Let's say we're starting with 4 times 4. Now, we all know, or let's start with 2 times 2. Now, yes, we all know 4 by 4. But I'll get to how this is useful later. And let's actually start at the end. Let's say we're going from here to here to 3 times 3. What new color to use? Let's just use this one. So, 2xn. Okay, so let's talk about all these things first. X is what we're starting with, so this is what we're starting with at 2 squared. Yeah, we could. So if we start with what we have here, we have 2 plus, and we're just going to start with this one. So we're only going one away from this, so that would be plus 1 Forgot to press shift. Is equal to to the power of 2 plus n to the power of 2, and n is 1, plus 2xn, which is 2 times 2 times 1. Or I think I screwed up somewhere. Oh well. So we have 2 squared, that's here. We have 4. Then we have plus 1 squared, which is going to be right there. That's what that is. This is the end zone. Not the end zone, the end zone. And then no, I did it right. And then it's 2 times 2 times 1, which is going to be these areas. We have 2 zones of 2 times 1. Now, if we change things up and made this, can't really edit numbers really on this, but oh well. Now, if we take this and copy in, paste it there, paste it there, paste it there. Now it would be this. And red. Because we have the initial 2 times 2. Okay, cool. Then n is still in this end zone. Since we moved it, since n is now 2, we move 2 away, so 1, 2. N has to fill in this area. And then the other numbers fill, and then 2 of them go over here. Now let's try using this in a little bit more of a functional method. Functional method, most people know 12 times 12 equals 144. Cool. But most people do not know what 13 times 13 is. Okay, so let's do this again. We have So this would be x plus 1 because it is going 1 away from this squared. So let's do this. So we already have the x squared, and that would be the 144. That's why we are using this, because we know where to start. So now we need to add the n squared, which is, of course, 1, because we're only moving 1 away. So it's going to be that. Then we add 2x, 2 times x times 1. So x started out as 12, so we are adding another 24. So that would be 160. 4 plus 4 plus 1 is 9, yes. So that is 13 squared. I actually do not know 13 squared. Here's the fun part. And again, you can actually do this for non-equal numbers. It's just that this term right here needs to change a little bit, because we now have to deal with side A and side B. Or actually, this term also has to change. These all have to change. Instead of this, instead of all those terms, this all, yeah, this also has to change. These are just, this is just for squared. If you want to do it a universal one, this is more or less how you would have to do it. And this is going to take up the entire page, I'm pretty sure. So let's start from the beginning. So it would be A times B plus yeah, A times B plus N. And that would be why are you saying that this is that's a plus? How is that correct? So yeah, it would be A, which would be equals A times B, and then plus N, N squared N squared plus A times N plus B times N. B times N. Which, if you want to see it on this, what we are essentially doing is just, we can do a problem where we just get rid of that row. row, and we and filling it in like this, and this would then have to fill in that. So we now essentially have so what we have now, instead of all of this type of stuff, we have 2 times 3, and we're moving over. And we are moving over to 3 times 4. Why is that a... I said 2, right? And it's the same type of thing. You add one, you add 2 for here, 3 for here, and then 1 for here. Oh wait, no, this should be yeah, you can tell I didn't start. It should be AN plus BN is what I should have put down right there. Because we have A, which would be here, plus N is 3, and then B, which would be here, plus N, boom. And that should be also times. There we go. I meant to grab it. I didn't want it to finalize. So yeah, let's get rid of this. This is wrong. Seven times EN. That's more like it. That's what this actually comes out to be. So sorry for past selves. But yeah. So if we want to look at this as the long ways, so we have, oh, it's plus N. Oh, come on, Michael. Sorry again. They really need to have 2 different things. Okay. Now this is going to be the correct thing. Here, let's move this over first with make things easier. Okay. So we have A plus N times B plus N. I knew I needed more room. Apparently that was not enough. Okay, now that's more. That's right. I did not think about actually doing this formula before I started recording. I apologize. Now that we have that out of the way, let's actually do this. So we have not the letter spelled or the spelling thing then. Now we have 2 plus 1 times 3 plus 1 equals 2 times 3 plus 1 squared plus 2 times 1 plus 3 times 1. There we go. And again, if you extended this out 1 and extended that out by 1, then it would be this would be 2, this would be 2, this would be 2, this would be 2, and this would be 2. So it'd be another 6, another 6, another 4, another 4, and that would be it. So it'd be, so you start off with your 6 because that's where you started off with, and then you would go out. Okay. To try to put all this stuff together. So and it actually does work backwards too. Like if you are going from, if you are going from say you knew 12 times 12 but you didn't know 11 times 11, for instance, it works the same way backward. You would just subtract n, but then you would have to well, yeah, it would be subtract n squared, but on top of that you would also have to subtract the new lowest number. So you would also have to subtract minus 12 minus n times 2, because this is the new number that you are subtracting 2. So that's the only real difference, is that it's always the smallest number that you want multiplying by 2. So if you look at this, 12. So we have 12 times 12. Like I said, I already know that is 144. And I already do know what 11 times 11 is. So you already saw that. But then we would minus n squared, which is minus 1. And you would also minus 11 times 2, which means you would be doing 144 minus 22, 23. 23, which is 121. Right? Yes. This is yeah. So yeah, let's do this entire thing together. I want to find the square of 25. This is what I want to find. It is the square of 25. I do not know the square of 25. I just don't know it. I honestly don't. But we already have everything we need to figure it out. Because we know that 24 is just 12, so 244. So this is 12 squared right here. And then we just have to times that by 4. Which is equal to, see, 4 times u is 4, but 4 times u is 16, so that'd be 5. 1, 5, 76. Or which is the same as 24 squared, which means now we can go to our other formula, which is we now know it's 576, and then we need to go up 1. Actually, no. It takes so long to do it now. It never used to take that. Let's make this 6 instead. Yeah, I'll make it a little bit more complex. There we go. So we're changing it to 26 on the fly. We still start at the same point because we still know 12 squared, and then we can get to 24 squared. But now we have the starting point of 256. 256. Now we know how to get up to the next one, which is um, we will add 4 because that is the difference shift because we are going from 24 here, we're to 26. So the two, so the difference is 2. So we times that by 2, and then we also add 24 uh, times 2 times or times plus times plus times 2 times 2, and that's going to be 48, which is going to be a grand total of 576 plus 48. Wait, the 20 24, so 48, 92, wait, 48. Did that work out perfectly like that? Okay. 48 times 2 is 96 plus 4 is okay 100. I did not know that. Yeah, 48, which is 80 plus 16, 90. Yeah, yeah, yeah. Again, my brain doesn't work very well. So yeah, we have a 96 here, and then we have plus 4, which means it's plus 100. I was not expecting that at all. Um, which means our grand total would be 676 is 26 squared. Now I'm going to have to double check that just because of my brain doesn't work all the time because I keep on saying uh yeah 26 times 26. Yeah, yeah, there it is. 676. So again, what we did here is let's clear this. We started off with 12 times 12 because I already knew that was 144. And from 144, I can times that by 4 to get 576. And then I went up 2. So I then had so I had 2 times 2 2 times 2 uh plus 24, and then I times 2 because of the two sides, and then I times 2 because of the 2 additional, because I'm actually going 2 out. And that was, yeah, 100. That's insane. I did not expect that to come out like that. Holy crap, it's already been 40 minutes. I was not expecting this one to be taking this long. Um, this is supposed to be ways to making your math actually faster because, like I said, a lot of us know up to 12 times tables, and if not, you know up to 10. And 10 is even easier because, if you start at 10, or start at 10 and you have 100, and you're going up to like 15, well, 15 is another is 5 times 5 and for the n because you're going up plus 5. And then we have um and then we have another and then we add 10 times 2, that's a plus, Michael, times 2 times 5, so it'd be another 10 times 10, so that's another 100, so that's 200, and which means it would be 225. And if we go back to the thing, 15 times 15 is in fact 225. Now, I usually try to use this mental math wise. Sometimes I miss a digit or forget how numbers work. So there is that added complexity. Whether or not to use this is how well you can keep track of stuff in your head. But it is still a nice little thing to know overall. Okay, well, I was not expecting this to be 15 minutes long or however long with what it is right now. Um, and it's just me just wanting to show a couple of funny little tricks on math, especially when it comes to squares. I don't know why I have been focusing so much on squares when I start doing math on this. But it's just how it's been working. And thank you for watching. I'm the car bum. Now get off my corner.